Hello, Algebra 2 students. Welcome to our Skill 7 notes, which will be about factoring by grouping. So the first thing I want to do is review how to solve polynomials, since we haven't done any of that this year. To solve a polynomial, first of all, we want it to be in factored form. So the first deal is we're going to factor our polynomial. But once a polynomial is factored, and you can always tell it's factored because two things. You'll see sets of parentheses, and you'll see it equaling 0. When you see it in that format, that means we are factored, and we're going to use what's called the zero product property to find the solutions. What that's saying is when you take the product of many things and the product equals 0, that means each one of the factors, each one of them could have been 0 in order to make that happen. So when we factor a polynomial, we want to find the x values that make each factor equal to 0. All right, so these first couple examples, I already give you the factored form. What we're going to do is we're going to find the roots, also known as zeros or solutions. When you hear any of these words related to factoring or polynomials, they all mean the same thing. The roots are the zeros are the solutions, the roots are the solutions. Okay, so just get used to those three words all being used interchangeably. All right, so in our first example, we have x minus 4 as a factor, 2x plus 5 is a factor, and x squared minus 3 is a factor, and it's already set equal to 0, so we can go directly to the zero product property. So I'm going to start with the x minus 4, and I'm going to set that equal to 0. Well, this one's pretty easy to solve. I'm adding 4 to both sides, so I get x equals 4. That will be one of our solutions. For the middle factor, again, just set that factor equal to 0 and solve for x. So first we subtract 5, and then we divide by 2. And we get x equals negative 5 halves. If you wrote that as the decimal negative 2.5, that would be fine as well. The last one, we're going to solve by taking x squared minus 3 equals 0. We solve this first by adding 3 to both sides, and we get x squared equals 3. Well, keep in mind we don't want x squared, we want x. So we're going to take the square root of both sides, and we'd have x equals plus or minus square root of 3. So note both solutions are going to work here. All right, let's look at the next one. Same deal here. We have 3 different factors, and it's set equal to 0. So we just set each factor equal to 0. Some of you on these more simple ones may not need to actually write out the equation. You may be able to solve this without having to write this, but I do it because I want to make sure everybody understands. Okay, so we have our first two solutions. The last one here, I'm going to work up here. We get 2x squared minus 5 equals 0. So we add 5 to both sides first. Then we divide by 2, so we get x squared equals 5 halves. And then we take the square root of both sides, and I'm not going to bother simplifying this. I'm just going to call it plus or minus square root of 5 halves. Okay, I'll just leave it like that. We will talk later on about rationalizing, but for now, this answer is acceptable. Okay, so we have now solved two polynomials when they were already factored. The process is you just set each factor equal to 0. So now let's talk about how to factor something called a quadrinomial. A quadrinomial, think about the fact that we have the word quad in the front. So quad means we have 4 terms. So if a quadratic equation has 4 terms in it, I guess it wouldn't necessarily be quadratic. We'll just say if an equation, okay? If it has 4 terms in it, we will always factor by grouping. Or at least we'll always test to see if we can factor by grouping. Not all 4-term polynomials will factor by grouping. but we will check and see. The examples we'll look at will be nice, but just know that as you study higher level mathematics, you may not end up with something that factors with 4 terms, but that's a bridge to cross another day. First step is to rearrange the polynomial in standard form. Okay, so as a reminder, that means high exponent down to low exponent, or constant. Okay, so we always want to make sure we go in that order when we write our polynomial. The way we factor is, once it's written in standard form, we're going to group the first 2 terms and the last 2 terms together. The third step, we're going to factor out the GCF, greatest common factor, in each group and rewrite. At this step, your group should be the same if it works out. This is the part where I was trying to emphasize earlier. Not all 4-term polynomials are going to factor by grouping. But if your GCFs, if your groups anyway, end up being the same, not the GCFs, but the groups that are left behind are the same, then you're going to be able to factor. And we're going to write our factor in a pattern such as the GCFs that we factored out is one factor, and the things that were the same is the other factor. And if asked to solve an equation, we set each factor equal to 0 and solve. Now, in all of our examples today, I'm going to be nice and make it to where it's already equal to 0, so we don't have to rewrite the polynomial. But just know that in future lessons, when you're working with solving any kind of a polynomial equation like this, you may have to remember to get one side equal to 0 first. But I'm going to be kind today. All right, so solving this equation, we have 3x cubed plus 4x squared minus 21x minus 28 equals 0. We want to solve this by factoring. All right, so right away, I'm going to factor the first 2 terms. Oops, let me make that a little bit nicer here because I'm sorry. Okay, try not to cover up that minus sign. I want that minus sign to still show. Okay, so we factor them first groups together, and now I'm going to look at these 2 terms in the first group. I have 3x cubed and I have 4x squared. Well, I know 3 and 4 can only be divided by 1, but x cubed and x squared I could divide by x squared. So I know that 1x squared, or just simply x squared, is a GCF of that group. And I'm going to rewrite what's left over by dividing those terms by x squared. So 3 divided by 1 is 3. X cubed divided by x squared is just x. 4 divided by 1 is 4. And x squared divided by itself, well, that's it. So I made my parentheses a little too far over. That's our first factored group. Now, before I get started with the next part, just know that we have a minus sign in the middle, so bring that down. And I'm going to give you a little hint. This group, you want it to end up being 3x plus 4. So think about that as you're trying to decide what to divide these by. Let's see, if I know that I need to end up with 3x plus 4, first of all, please note that when you factor out this minus sign, when you bring that minus sign down, you're factoring out a negative. So you're going to be dividing these terms by a negative number, and it will be negative 7. Okay, so I bring the minus 7 out to the front, and then I divide these terms by negative 7. So negative 21x divided by negative 7 is positive 3x. And negative 28 divided by negative 7 is positive 4. Okay, so the good news here is that my groups are the same. Okay. So that becomes one of our factors, 3x plus 4. Those are what I call the sames. So if you remember back up to my little pattern up above, I said I make GCFs one factor, the sames the other factor. Okay, so my sames are 3x plus 4. I like to cross them out to be able to visually see what's left over. The other factor is x squared minus 7. Those were the things that were the GCFs. Okay? GCFs do not have to be the same. Just the groupings that were left over with have to be the same. Now, remember, in the context of this problem, we were solving an equation, so we set this equal to 0, and this should now look like what we had above in our first two examples. So now we're just going to take this factor, set it equal to 0, and solve for x. Take the square root, and that gives us x equals plus or minus square root of 7. That's one of our solutions. The other factor, we just solve out to the side, set it equal to 0. Solve for x by using our inverse operations, and we get x equals negative 4/3. Alrighty, how are we feeling so far? Alright, for these last two examples, note that sometimes you may have to factor out a GCF before you can do anything. So if I look at example 4, I've got 2x to the fourth plus 8x to the third minus 5x squared minus 20x. Clearly, all terms can be divided by x. Since I could divide by x, I'm going to factor out that x, and I'm going to write what's left over. So I'm just applying my exponent properties where I subtract the exponents. Remember, these are x to the ones. So I'm just subtracting the exponents. Okay. All right, and so now what I'm going to look at is just what's inside the parentheses here. Okay. So looking at that part, I'm going to highlight it real quick. Maybe. I don't know how to highlight on here. No, maybe I'm not going to highlight. It's okay. I'll use just a different color here. I'll use red. And I'm going to show that I'm going to factor the first two terms and the last two terms. I'm going to go ahead and make sure that my x comes down to the bottom so I don't forget it, because a lot of people forget that GCF they pulled out. Looking in the first two terms, I can divide the numbers by 2, and I could divide the variables by x squared. So I know that 2x squared is a GCF. My leftover factor is x plus 4. Now, going over to the other side, I know I need to end up with an x plus 4 over here. I have a minus in the middle, so let's bring down that minus. And I can divide these numbers by negative 5. Okay, and when I do that, I end up with x plus 4. So my groups are the same, so I know that x plus 4 will be a factor. And once I've used those, I know that 2x squared minus 5 will be the other factor. Those are the GCFs. All right, so now we are ready to solve for our particular factors. A lot of people forget about this first factor. X equals 0 is a solution. So for that, I literally just say x equals 0. There's nothing to solve. That's a solution. Now the next one, 2x squared minus 5 equals 0. So I need to add 5 to both sides. Divide by 2. We already saw a solution like this. Take the square root of both sides, get rid of the square, and we get plus or minus square root of 5/2. That'll be another solution. And then finally we have the easiest solution, well, the second easiest solution in this one. To solve this out, x equals negative 4. So x equals 0, x equals negative 4, and x equals plus or minus square root of 5/2 are our 4 solutions. And I say 4 solutions because the plus or minus here tells us we have 2 solutions within that one. All right, last one here. This one, notice that all terms are divisible not just by x, but we can also divide by, it looks like 2. So we're going to divide by 2x. So 2x will be a factor, which we need to remember to bring down. The leftover stuff, we get 3x cubed minus 4x squared minus 6x plus 8. Okay, and now just like before, I only want to worry about what's in the parentheses, so I'm going to I'm going to group the first two and the last two together. In the first group, I can divide the numbers just by 1, and the x's I can divide by x squared. So 1x squared, or just simply x squared, is the GCF. When I divide these out, I get 3x minus 4. Remember, I want 3x minus 4 over here as well, so keep that in mind. I have a minus sign in the middle, and it looks like in order to make these 3x minus 4s, I'm dividing by -2. Okay, so now my sames are the same. My GCFs are made up of x squared minus 2. And then 3x minus 4 is the GCFs. Alright, so now we have our factored form. So we just simply solve each factor by setting them equal to 0. So for 2x equals 0, divide by 2, and you still get x equals 0. For this one, you get x squared minus 2 equals 0. So we add 2, and we get x squared equals 2. Square root of x squared is just x. And plus or minus radical 2. Don't forget the plus or minus. And on the last one, we have 3x minus 4 equals 0. So we're adding 4 to both sides. We get 3x equals 4. Divide by 3. And we get x equals 4/3. And now we have all of our solutions. And now that you've watched this video, you should be able to do some practice problems on Delta Math.